Hello guys, welcome to my online lessons. Because of the coronavirus, we have to move everything online. So in the next week or so, this is pretty much going to be what we'll be doing. I try to keep everything the same as if we are physically contacting at school. You will still see my OneNote notes. You will see me writing like what I usually do in class, and you'll also hear my voice. Although you will see my voice being a little bit different because I usually will speed up a little bit just to try to cut the video a little bit short. Okay, so we are hopping onto Unit 7, Geometry. We will start with Unit 10, Square Roots, Pythagorean Theorem, and Cube Roots. Okay, we're gonna start with we're gonna start with square roots today. Okay, so here we go. Our title for today is square roots. Here are a few examples over here. I think most of us know the answers already. This is quite intuitive. So let's go through them. You can pause the video now to kind of give yourself a few seconds to answer. Whenever you're ready, you can continue. Okay, so here we go. Root 4, this is equal to 2. Root 9, this is equal to 3. Root 16, this is equal to 4. Okay, so now here's a question over here. Here's an interesting part. We got minus square root 64. What is that? This is actually whatever you see over here, square root 84, and whatever you believe that is. Square root 84, we should immediately think of 8 over here. But not just because I have a minus sign right in the front, so we actually put a minus over here. So the answer is minus 8 actually, okay? So the whole purpose of this is to try to get you guys understand that a square root over here will only give you a positive answer over here. If you want a minus value over here, you should put a minus square root sign over here. Okay, for example, if you want a minus 2, then you should put a minus square root 4, and that will give you minus 2. Okay, if you just simply said square root 4, you should be only talking about a positive 2 over here. Okay, so that's the first thing. Now the next thing is just a few observations over here. You probably notice that 2 times 2 equals 4, and then the square root 4 times square root 4 is also going to give you 4. Okay, you can punch in the calculator if you don't believe me, but basically, this is the case. Right, so 2 observations now. The first thing is, this actually tells us that square root 4 is equal to 2. Why is that? Because both of them, if you multiply the same person twice, okay, let's say in this case, 2 times 2 gives you 4. If you multiply someone that looks completely different over here, that you do exactly the same thing, your answer is also 4. So what does that tell us? That tells us something. That tells us that our 2 is actually equal to square root 4. Okay, so only if they're the same, if we're doing the same thing over here, that should give us the same answer over here. Right, so that's the first thing. Second thing is, whenever we multiply 2 things with hat together, the hat actually get cancelled out. Okay, what does that mean over here? You can actually see that from the second line over here. That, for example, if you have root 4 times root 4, you actually see that magically the 4, you basically just combine them together and then put the hat away, basically. Okay, so for example, this root 9 times root 9 over here will actually give you just a 9. Moving on to the next part, we have rules for square roots over here. Now the first thing is quite intuitive. What is the square root of 0? Square root of 0 is equal to 0. Okay, second part is, this is probably a little bit tricky over here, but it's actually quite easy. If you look at the first guy over here, let me use blue to kind of illustrate what exactly is happening over here. Okay, so what does that thing over here tells us? This is basically saying that we have 2 square root a multiplying together, right? So you have whatever square means whatever times whatever. Okay, but then in this case over here, this is actually exactly the same as the third one over here, the third expression over here. So yeah, that's exactly what it means over here. And from our previous observation, basically we're saying that if you have 2 hats over here, put them together, and that becomes just one single A over here. Okay, so that part makes sense. Okay, now the final part over here is this guy over here. Right, so why are they all the same over here? What does that really mean? Well, that basically means this. Okay, this basically means that under the hat over here, you have 2 A's multiplying together over here. Okay, you can think about them as breaking the hat over here, like this. Okay, so they're actually exactly the same thing over here. Okay, this is actually part of the rules that we're talking about over here. Okay, so that's what it says. That's why all of them are exactly the same. Now the third rule and the fourth rule, they are pretty much similar over here. Basically, we're saying that if you're doing multiplication and division, you actually get to share the hat over here. Okay, so 2 people, okay, for example, 2 people, there's a little A over here, and there's a little B over here. Okay, if they are multiplying together, this is what's going to happen over here. Okay, what's going to happen is A is going to go here, and B is also going to go here. Multiplication over here will also go here. Okay, and then surprisingly, magically, we actually only need one big hat over here. Okay, if that makes sense at all. Now for division, it's actually exactly the same thing over here. If both of us has hats over here, we can just put one hat inside the whole multiplication and division. But notice one thing that you cannot do. Okay, one thing that you cannot do is, for example, if I do a root a plus root b, you cannot actually put the addition under the same hat over here. Okay, same thing. If you have minus, you cannot put the hat under them. Okay, you cannot share the same hat over here. The hat has to be separated. Okay, you can share the same hat only if you have multiplication and division over here. So here are our rules over here. We have 4 rules over here, like I just said over here. Please keep in mind that we have 2 extra ones that are not mentioned on the textbook, but I think those are very important. So make sure you keep in mind that if you have addition and subtractions, we don't actually get to share the hat. Now recall, an irrational number is a number that cannot be expressed as a fraction. Okay, so now the question is, which of the following are irrational? Okay, our keyword is, if you're rational, then you cannot be expressed as a fraction over here. Okay, we are asking which ones are irrational. That basically means we're asking which ones cannot be expressed as a fraction over here. If you are already a fraction, like the first one, then of course you are not irrational. Okay, so you're not what we're looking for over here. So this is not. Okay, right, this is not irrational. This is we call that rational. Okay, if you're not irrational, then you are rational. Okay, if you're not a bad person, then you're a good person. That kind of sense. Okay. The next one over here, can you be expressed as a fraction? If you can, then you're not. Okay. Root 4, it's actually 2. 2 can be written as 2 over y. So you're actually not that bad over here. Okay, you're not a bad guy. Okay, let's keep going. Part C. Okay, root 5. We can actually think about a whole number that can simplify this into. Okay, so the thing is, if you actually type this thing over here into the calculator, you will find that the answer is actually 2.236 blah 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 blah. Okay, that kind of number cannot be expressed as an. Okay, so in this case, you can write that this is 2.2 something. Right, but then in this case, this is actually a irrational over here. Right, it's bad, irrational. Okay, the next one over here, this is actually minus 5. Minus 5 can be written as minus 5 over 1, so you are safe, you are not a bad guy. Okay, so this guy over here is minus 3 over 1, again, you are not bad. This one, minus square root 32. 32 looks pretty friendly, but in fact, if you actually put in minus square root 32, you will get minus 5.656 blah 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 over here. So this is actually irrational. Okay, 0 is just 0, which is equal to, you can write 0 as 0 over anything, right? 0 over 1, let's say. Right, so this is a fraction over here, so you're not bad. But as long as you can be written as a fraction, you're good. Okay, you're not bad. You're not what we're looking for over here. Okay, so 2.23, this could actually be written as 233 over 100 over here. Okay, so this is also not what we're hunting for. Okay, so in this case, we have 2 rationals. We have 2 terminologies that we need to pick up. The first one is, any number with a square root hat is called a radical. Radical. Okay, so as long as you see the hat, you quickly react. Radical. Okay, a random dude walking on the street with a hat, radical. For those people with a hat, if they cannot be written as a fraction, then we call that a surd. Surd. Okay, so these two things are different. Okay, rational and surd. Okay, surd is a special type of radical. Okay, which ones are radical and which ones are surd? Let's work on them. Okay, so the first guy over here, you are actually not radical. You're not radical. If you're not radical, then for sure you're not a surd. Not a surd. Okay. Second one, you don't have. Do you have a hat? You don't have a hat. You're not radical. You're not radical. Okay. As long as you're not radical, then you're not a surd. Okay. Third one, do you have a hat? Yes, I have a hat. Then you are a radical. Okay. You have a hat, but you could actually take out the hat. Okay, if you simplify yourself. Okay, or to be precise, you could actually be written as a fraction. That means you are not a surd. Okay, you're not a surd. Okay, keep going. This guy, do we have a hat? Yes, we have a hat. Okay, radical. Okay, you have a hat now. Can you take out your hat? Can you eventually become a fraction? You cannot actually, because we know that square root 15, it cannot be represented as a straightforward number over here. Square root 16 could. Okay, square root 15, no. So in this case over here, you are actually a surd. Okay, you are actually a surd. Because you are irrational. Okay, let's keep going. Do we have a hat? Yes, we do. So this is radical. Okay, can we actually simplify ourselves? Yes, we could actually. You can actually simplify yourself to be minus a. This is minus a over 1. You can be simplified as a fraction. That means you're not bad. Okay, so you're not a surd. Okay, this guy we actually came across before. Minus square root 32. Do we have a hat? Yes, we do. Okay, radical. And you are actually a surd because square root 32 cannot be actually written as a fraction. So we are done. Okay, 0, do we have a hat? We don't have a hat over here, so this is actually not a rational. Sorry, not a radical. Okay, if you're not a radical, then end of the story, you're not surd for sure. Okay, last one. Do we have a hat? Yes, we do. Okay, if you have a hat over here, can you take out a hat and become a fraction? Yes, we could actually. This is actually 0. 0 is equal to 0 over 1. Okay, then in that case, that means you're not bad. You're not a surd. Okay, we have some more examples over here. Take a look at these 2 questions. Pause the video if you want. Whenever you're ready, we will get going. Okay, So here we go. Simplify that. Remember our rule. Okay, remember our rules. Square root 11 square, you can actually write that as square root 11 times square root 11. Okay, if you have two same things over here, two same things with the same hat, then we can actually take out a hat and just write ourselves. The answer is 11. Okay, second part. This one is a little bit trickier. Okay, first of all, we follow whatever the square root, the power of 2 wants us to do. Whatever the power wants us to do is basically saying that we want to multiply these together over here. Right, we have two things multiplying together. Okay, but when we multiply, we can actually move around. Okay, we can collect the numbers and numbers together, and we can collect the hat and hat together. Okay, so 2 times 2 will give you a 4. Okay, so this gives you a 4. Now this root 3 times root 3 will give you a 3 actually. Okay, remember the rule over here, 2 hats over here, you get to take it out. Okay, 4 times 3 gives you 12. The answer is 12. Now, last example over here, again pause the video, if you are ready, we can get going. Okay, so this part A over here is also part of the rules over here. If you are multiplying, the two numbers together, even if the two numbers are different, as long as we are having the hat and as long as we're doing either multiplication or division, we actually get to share the same hat. Okay, so this guy over here and this guy, even though we're different over here, that's fine. Okay, we share the same hat, inside, multiply. Okay, 3 times 5 is equal to 15, so we actually have square root 15 for part A. Now part B, it's pretty much the same thing over here, except this is division. Okay, so now we have this guy over here, and this guy. Okay, now the first thing that we can do is we can actually stretch out the hat. Okay, so we got 18, and then we got 3 over here. Now, because we are both under the hat, we can just do our own division. Okay, so 18 divided by 3 is 6. And then you have the root outside, you're done, square root 6. Last one, part C. Okay, because we are already inside the hat already, so we can do whatever we want over here. But you probably realize that we cannot actually simplify by canceling anything out over here. There's no common factors over here. So what are we supposed to do? Well, if you think about it, we can also do the other way around. Just because we can combine a hat, that means we can also separate the hat over here. Right, so this is root 4 on the top, this is going to be root 9 on the top. Hey, we actually realize we have square root 4 being 2. Okay, so this is actually 2 over here, so the whole thing is 2. Okay, and then the square root 9 over here is just 3. The answer is just 2 over 3. So this is what's going to happen every day. Every day you're going to, at the end of the video, you're going to see the homework questions. But you can also find these homework numbers on PowerSchool Learning as well. Well, thank you for watching. Have a good day. Stay safe. I'll see you next lesson. Peace.